Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 14 video on the subtopic of floating and sinking of a solid in a liquid. In this video, I will I will try to explain with the best of my ability that when a body is immersed in a liquid, and if the body has a density greater than the density of the liquid, then the body will sink. That is, if rho 1 is the density of a body, rho 2 is the density of the liquid. If rho 1 greater than rho 2, then the body will sink, which means that it will go down to the bottom of the liquid. So this subtopic is part of the chapter Physical Quantities and Measurements, and this video is part of the playlist ICSE Physics for Class 8, where I primarily discuss key concepts and formula related to numerical problem solving. If you if you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel, and also in that case do not forget to press the bell icon so that you will be notified by my future videos. So let's start part 14 video, where I will discuss that a body sinks in a liquid when the density of body is more than the density of the liquid. Okay, so I have prepared a very quick notes and diagram to explain that if rho 1 is the density of the body and rho 2 is the density of the liquid, we are considering the CGS unit system. So let the volume of the body be VML, and the density of the body be rho 1 gram per centimeter cube, and density of the liquid be rho 2 gram per centimeter cube, where we know that rho 1 is greater than rho 2. Also, let I have in the diagram, it is a situation where the body is partially immersed in the liquid, that is, and the volume of the immersed part of the body is V1 ml. Now V1 is obviously should be greater than 0, that is, at least some part of the body is immersed in the liquid. So V1 is greater than 0 and it is less than V, that is, the body is partially immersed, not wholly immersed. That's why V1 is less than V. This is the scenario. Okay. Now, as we can see, based on Archimedes Principle, there is a downward force. Vertically, there is a force. The weight of the body W is acting vertically downwards, and the buoyant force Fb is acting vertically upwards on the body. Now, whether the body will sink or float is entirely will depend on the relative values of W and Fb. That is, whether Fb is greater than W or equal to W or less than W. Now, the reason that the body will sink to the bottom of the liquid is because the weight of the body is always be greater than the buoyant force. No matter what the value of V1 is, whether it is partially immersed or wholly immersed, that is, whatever the value of V1 is, if the weight, that is W, is always greater than the buoyant force Fb, then we will have, as you can see, the net force will act downwards, which is the net force is W minus Fb, which is also the apparent weight of the body in the liquid. Now, if the apparent weight of the body in the liquid is greater than 0, obviously that weight will tend to sink the body more towards the bottom of the liquid, and finally it will sink completely. So this is the basic reason why the body will sink. Now, the whole point of discussion is that we need to prove that if the density of the body is greater than the density of the liquid, then the body will sink. So obviously, this factor, that W is always greater than Fb, is obviously dependent on rho 1 and rho 2. That is what we will now see. Why W is greater than Fb when rho 1 is greater than rho 2. Okay. So in this situation where the volume of the immersed part of the body is V1, what is FB? FB, that is the buoyant force acting upwards, will be the weight of the displaced liquid, and the volume of the displaced liquid will be V1. So its mass will be, the mass of the displaced liquid will be V1 rho 1 gram. Of course, so the mass is V1 rho 1 gram, and the force FB will be gram force. Okay. Now, what is weight? We have considered the total volume of the body to be Vml, and the density of the body is rho 1 gram per centimeter cube. So the mass, so the weight of the body is mass gram force. What is mass? V rho 1. This much gram force. So is it the fact that so now if indeed it is so now let's see whether W is always greater than FB if rho 1 is greater than rho 2. I'm sorry, the buoyant force FB will be V1 multiplied by rho 2, as rho 2 is the density of the liquid. Okay. Now let's compare W and FB. W and FB. Okay. Let's do one thing. Let's divide. Let's take the division of W. Let's find what is W by FB. W by FB is coming out to be V rho 1 divided by V1 rho 2. Okay. Now, do you think what will be the value of V rho 1 divided by V1 rho 2? Will it be greater than 1 or less than 1? Since, let's see, we know that V is always greater than V1. We have considered the fact that the body is partially immersed. So V1 is less than V. That is, V is greater than V1. This implies if I divide both sides by V1, I have V by V1 greater than V1 by V1. So this implies that V by V1 is greater than 1. So okay. So what is W by FB? I can simplify it. V by V1 multiplied by rho 1 by rho 2. Okay. So I got V by V1 is greater than 1, which is obvious from common sense. Now let's see. Also, we know that rho 1 is greater than rho 2. So if I divide both sides by rho 2, I can divide both sides in the inequality. I can divide both sides by some non-zero positive number, and the inequality remains the same. Obviously, rho 1 and rho 2 are positive numbers. So rho 1 divided sorry, rho 1 by rho 2 is greater than rho 2 by rho 1. This implies rho 1 by rho 2 is greater than 1. So if V by V1 is greater than 1 and rho 1 by rho 2 is greater than 1, we must have V by V1 multiplied by rho 1 by rho 2 should be greater than 1 multiplied by 1. This implies V rho 1 by V1 rho 2 is greater than 1. This implies what is V rho 1 by V1 rho 2? That is nothing but W by FB. W by FB. So we got W by FB is greater than 1. Now remember, this is this we got when V1 is less than V. Okay, that is the body's part. So irrespective of whatever the value of V1 is, as long as V1 is less than V, we saw that W is okay. So this implies that W is greater than FB. So we got the situation the condition, so this one, the W is greater than FB, which means that the body will sink. Now, if V1 becomes equal to, if V1 is equal to V, that is the body is completely immersed. In that case, what happens? V by V1 is equal to V by V is equal to 1, and this implies that V by V1 is equal to 1, and this relation, that is rho 1 by rho 2 greater than 1, will always remain true, because rho 1 is greater than rho 2. These two facts, if I multiply, I will get V by V1 multiplied by rho 1 by rho 2. This should be greater than 1 multiplied, greater than equal to 1 multiplied by 1. Why greater than equal to? Because no, since rho 1 by rho 2 is greater than 1 and V1 and V by V1, okay, so what is now, when V1 is equal to V, then V by V1 is equal to 1. Then what is W by FB? This implies W by FB was equal to V rho 1 by V1 rho 2. V rho 1 by V1 rho 2. Now, since V1 is equal to V, we have V rho 1 divided by V rho 2, which is equal to rho 1 by rho 2, rho 1 by rho 2. Now, we know that rho 1 by rho 2 is greater than 1. So, this implies that W by FB will be greater than 1 even when V1 is equal to V, that is when the body is wholly immersed in the liquid. Now, once the body is wholly immersed in the liquid, then that is the scenario where the buoyant force will be maximum. The buoyant force, the maximum value of the buoyant force will be when the body is wholly immersed. It cannot be more than that. So we can clearly see that when the density rho 1 is greater than rho 2, the body will always sink, because we will always have the weight will always be greater than the buoyant force, no matter whether the body is partially immersed in the liquid or wholly immersed in the liquid. W will always be greater than FB, which means that a net force of W minus FB will act vertically downwards, and that weight will will tend to move the body more and more down towards the bottom of the liquid, which means that the body will sink. I hope I was able to explain and clarify the concept behind the fact that a body of density higher than the density of a liquid will sink in the liquid. In the next video, I will consider the case when the density of the body is equal to the density of the liquid and see what happens, whether the body sinks or floats. We will see in the next video. I hope this video was beneficial. If it is so, then please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. So there are three cases, as you know, that we will discuss regarding the floating and sinking of a solid in a liquid. In the case 1, in this video, we discussed when rho 1 is greater than rho 2, that is density of body is greater than density of liquid. In the next video, that is case 2, I will discuss when the density of the body is equal to the density of the liquid, that is rho 1 is equal to rho 2. And in the next video, that is case 3, I will discuss what will happen if the density of the body is less than the density of the liquid, that is rho 1 is less than rho 2. So these videos are coming soon, so please stay tuned. I will end the video here. Thanks for watching, and until the next video, take care and bye.